Hello, everybody. Here we are, 4.4 matching equations and graphs. And by now, we'll have taken a little detour to do our house project. And so these notes will be a little bit of a combination of like what the textbook tells you to do in order to solve these, and hopefully like applying some of the things that we learned during our project. So I want to remind you of slope-intercept form. And this is that y equals mx plus b. And this is what we're using a lot of the time during our project. Remember, m is the slope. So that's how, flat or vertical our line is, how steep or how steep our line is. And b is where it, intercepts the y-axis. So remember, if we were making, our beautiful house and you needed to put a roof on that thing, this line right here might be something like y equals x plus 60. So maybe you wanted it to intercept, the line up at 60. And if you needed to make the other side of the line, remember, your line might have been something like y equals negative x plus 60. So it's still intercepting at 60, but now it's going the other way because our positive y equals positive x moves like a check mark, and the y equals negative x moves down that way. So let's apply some of this to what we're learning today, and just some other kind of tools that we can use to match equations and graphs. So for this first one, let's rely on y equals mx plus b. Let's do that, and I can show you another way to look at it as well. But let's rely on this to solve to match these equations here with this line. Oh, there's one more thing that I want to point out, and that I think is really good to know, is that what matching in a line and an equation means. And so this line, let's say right here, this means that, it crosses at positive 4, and it's moving in our negative x way. So it has to be this one right here. It has to be a negative x. It crosses at positive 4. That's our y-intercept. Remember, it's crossing there at positive 4, and it's moving in the negative x direction. So it has to be that one. So that's A. And what this equation means is that at every single spot on this line, at every single dot here, at every single time and place, that the y equals a negative x plus 4. So let's choose some dot. Let's choose this dot right here is 3. The coordinates of this dot is 3, 1. So it's true at this dot, and remember that's our x coordinates first and then our y always, that 1 equals negative 3 plus 4. And yes, that's true. Negative 3 plus 4 does equal 1. So this is what this is saying. This equation is true that for every single dot on there, that whatever the y is equals a negative version of the x plus 4. So that's what that means. Let's look at our next ones, and let's use our y-intercept form. Looks like we have a line that's intercepting at negative 1. And so this must be A. We have the y-intercept at negative 1, so that's going to be line C. And then you can do a process of elimination, but looks like this one is intercepting at negative 3, which is negative 3 right there, line B. Okay, so that's one way to do it. Let's look at our next lines, and it's a little bit hard to see on your notes, but this is the y-axis, this one right here, and this is the x-axis, this one right here. And let me add some color to the other lines to help you out. This is line A, this is line B, and this is line C. So it's a little bit hard to see, I'm sorry, but this kind of off-centered cross is the x-axis and the y-axis. So for our first one, it looks like we have just a y value, which is going to give us a horizontal line, and it's a horizontal line at negative 1, negative 1x. That's at negative 1y. That's at negative 1y right there. That has to be C. let's look at this next one. There's kind of a couple ways we can think about this one. We can make it into x equals something. And the way that we can manipulate this equation, so currently it says 0 equals negative x plus 1. We can move this y over to the other side of the equation. So we can add a positive x to each side. And we'd be left with x, this cancels out, equals 1. And so can we find a line where this is our x values? Remember, where x equals 1. Looks like that's 0. That's 1 right there. So yes, looks like a equals that. And remember what I said about an equation, meaning that this information is true. So is it true that 0 equals negative 1 plus 1? Is it true that 0 equals negative 1 plus 1? Yeah, that's true. So we know that that line is line A. And this last one, I'm going to do again, kind of solve for x algebraically. We do have a process of elimination. We know that it's b. Again. But let's solve algebraically. So we want to find out what is x. We have 2 equals 2x subtract 3, and we want to isolate this x. So we're going to kind of undo the puzzle. Let's start by, we do the opposite of order of operations. Let's start by adding 3 to each side. So we get 5 equals 2x, because right here, negative 3x plus 3 equals 0. This 2 plus 3 gives us the 5, and we still have our 2x. And now to get the x by itself, it's currently being multiplied by 2, so let's divide by 2 on each side. And we get, this becomes 1. X equals 5 over 2, which is 2.5. And that does look like our line B is at 2.5. So that's another way to solve it, is to solve for x. Okay, let's look at number 3, and I'll give you another way to think about these. And I want us, for this one, to really focus on the idea that this equation, that every point on this line is going to make its equation true. So we can choose a dot on this line and see if it makes our equation true. So this dot is at 2, 3. So let's try it for the first one. Is it true, if we input the values in for A, that 2 plus 3 equals 5? Is that true? Yes, indeed, that does seem to be true. So I think there's a good indication that this is line C right there. We can test the dot in the other equations. I don't think it's necessary, but we could do that. So, is it true that 2 minus 3 equals 5? No. Is it true that 2 plus 3 equals negative 5? No. So it has to be that line. Let's choose, now this dot. This is at 1, 2, 3, negative 2. This dot is at 3, negative 2. So let's see, we can input the values and see if it's true. So is it true that 3 subtract negative 2 equals 5? So is it true, remember, subtracting a negative is like adding a positive. It does seem to be true that 3 plus 2 equals 5. So I think we've done it again. I would say that this one here is line B. But let's, for curiosity's sake, check it in the next one. Could it be true that 3 plus negative 2 equals 5? No. So that doesn't seem to be true for that line. And then let's do the last one. C, it has to be line A, but let's just prove it. Let's choose a dot right there. That is at negative 3, negative 2. And is it true that negative 3 plus negative 2 equals negative 5? Yes, indeed, it is true. So we know that that equation matches that line. These ones are nice. they don't intercept, so you know that they are gonna should be unique to their equation. There's ones. Okay, in the next one, I think in the next example, you'll see a little bit what I mean about some difficulty. They have 3 lines, 3 equations. And the next one, it's a little bit, or maybe number 5, it's a little bit. I'll tell you what I mean about having to kind of double check something. So here again, we have some nice lines in our slope-intercept form. Y equals mx plus b. So I would be very interested in this part where it crosses our y-axis. Looks like it crosses at positive 2. So any of these have positive 2? 2 of them do. This one is a negative 2, so it's not going to be that one. But here we have something, interesting. We have a positive x and we have a negative x. Is this line moving like a check mark? Yes, it is. So it's going to be a positive x. It can only be a right there. And then we can confirm that. We can choose any dot. Like let's choose this dot right here and just confirm that it's true. So that dot exists at 1, 3. So is it true that 3 equals 1 plus 2? Yes, that is true. So we know that we have the correct line, the correct equation for the correct line. Okay, let's do this last one, and I think we'll see a little bit what I'm talking about, that there might be, we have 3 equations, but we only have 3 lines. And the thing about a line, these equations could represent a line that shares a dot. So it could, we could have a line that looks like that. And we might have a line that looks something like that. So those 3 equations could represent 3 lines that look like that. And so it might be true that they share a spot in common. So we'll probably have to check 2. We'll have to check 2 spots to be able to know, do we have the right answer? Because we don't have 3 lines drawn, it could be true that they intersect at one particular dot. And so we'll need to check kind of more than one spot. So let's check out our first spot right here and see if they're true in our equation. So we have a dot that's 0, negative 1. So let's make a table of values here. We got one at 0 and negative 1. So let's see if that's true in our first equation. So is it true for A that 0 subtract negative 1 equals 4? So is it true that, subtracting a negative is like adding a positive? But is it true that 0 subtract negative 1, or that essentially 1 equals 4? Is that true? No, that's not true. So we know that this one doesn't work. Okay, so let's plop it into our next one and see what we get. Oh, B, not D. So let's try. Is it true that 0 subtract 4 times negative 1 equals 4? So is it true that 0 subtract negative 4 equals 4? Okay, subtracting negative 4 is like adding positive 4. So yes, indeed, it is true that positive 4 equals 4. Okay, that's one that works. Let's try now another dot and see if that one works. So here we have another dot. Looks like we got it at 4 and 0. And let's see if this works in our equation. So is it true, B, that 4 subtract 4 times 0 equals 4? So is it true that 4 take away nothing equals 4? Yeah, that is true. So it seems like we got 2 true ones for our second one. I'd say there's a good chance that that's the equation that describes our graph. We can confirm it, triple confirm it with one more dot. There's one I can see right there at negative 4, negative 2. So let's just check it for the sake of it. Let me scroll down a little bit. So is it true still for B that 4 times negative 4 subtract negative 2 Oh, I think I'm using the wrong one. Yeah, I'm using the wrong one. My bad. So is it true that -4 subtract 4